في واحد منكم فاتح المايك؟ في طالع لي وش كذا في السماعة يا شباب. في أحد فاتح المايك؟ معايا يا شباب ولا لا؟ ما حد يرد.
معاك يا دكتور بس هو ميوت.
طيب ممتاز ممتاز. طيب الآن let's look at the expected value of a function of random values. لو تتذكروا تكلمنا عنها قبل كذا، تكلمنا عنها when we talked about expected value of summation of alpha I xi, and we said that this is equal to summation of alpha I expected value of xi, right? So summation of weighted sum of random values, expected value of summation of weighted sum of random values is the same as the weighted expected values of every random value. Now let's look at the variance. So we'll repeat the same exercise for the variance. So here we have x equals summation or weighted sum of xi's, summation of alpha I xi. I goes from 1 to n. Let's find the variance of x. Last time we found the expected value of x. So expected value of x. لو ترجعوا كذا slide قبل كده. Now let's find the variance of x. Let's see. If we subtract the mean من x يصير x minus expected value of x. Okay. Which is, now if you just put expected value of x اللي وجدناها قبل كده inside the expected value of inside the expectation, then basically we get this. Summation I goes 1 to n alpha I, then multiplied by xi minus x bar, with the expected value of x. Now, if I want to find the variance, I simply need to find the expected value of x minus x bar all square, which is this one. This is by definition the variance of x. Expected value of x minus x bar, the whole square. So now, in order to find this, simply I take this, okay, I multiply it by each other inside the expectation. So it will be expected value of this summation, however, with I as an index, multiplied by the same summation with j as an index. Because I am squaring it, right? هذا هو السكوير. Goes like this. So I have double summation here, I and j, alpha I, alpha j, and then expected value, that is the expectation is linear, so I can take the expectation inside the summation. So expected value of xi minus xi bar multiplied by xj minus xj bar. Okay. Now I know that expected value of xi minus xi bar multiplied by xj bar, this is equal to, سميناها قبل كده الcovariance لو تتذكر. So I have double summation of alpha I, alpha j, then multiplied by the covariance between xi and xj. This is the variance of x, which is the weighted sum of alpha I xi. واضح يا شباب؟ هذا هو الفاريانس of the summation of weighted sum of random values. Now, the interesting part is when xi are uncorrelated. So if I have uncorrelated random values, I'm summing uncorrelated random values. Then in this case, what do I know about covariance? For I not equal to j, for two different random variables, xi and xj, since they are uncorrelated, this is 0. Right? And for I equal j, I am talking about the same random variable. Cxi xj is what? Is the variance of xi. When I equal j, we are talking about c xi xi, which is expected value of x minus x xi minus xi bar multiplied by the same xi minus xi bar, which is sigma xi square. Okay, so what I get is for uncorrelated xi's, the variance of the weighted sum, which is x equal summation of alpha I xi, is equal to the weighted sum of the variances. However, the weights here will be alpha I squared, not alpha I as in the summation. In the expectation was alpha I, here alpha I squared. Okay, Shabab? So if I have uncorrelated random variables, I'm summing them, then the variance of the sum, which is the random variable, that is the summation of multiple random variables, if they are uncorrelated, it's equal to the weighted sum of the variances. Tamam? Now, one thing related to characteristic function, only one slide, we'll talk about joint characteristic function. Joint is between x and y, for example. So we define the joint characteristic function between x and y, or if the joint characteristic function of x and y as phi xy of alpha gamma 1, gamma 2. So we have here two gammas, which is the expected value of, by definition, two exponentials, e to j omega x plus j omega 2y. Okay? Or you can write it as expected value of e to j omega 1 x, e to j omega 2 y. Either this or that, the same. So here I'm talking about two exponentials. I'm talking, when I take the expectation of them, I get the joint characteristic function. And I do that by simply, whatever inside here, I take it next to the, so I double integrate the joint PDF multiplied by e to j omega 1x plus j omega 2x. Okay, this is called two-dimensional Fourier transform. Now the opposite, if I want to find the joint PDF, I take the opposite of that, where basically I integrate the joint characteristic function multiplied by the joint exponential, e to minus now omega 1, j omega 1x minus j omega 2x. Okay? Now, again, why do we need to do this? Because it's extremely useful to finding joint moments. As we mentioned before, for example, here the n plus kth order moment can be generated by the joint characteristic function, with very similar to what we have done to single random variable. It will be minus j to the power n plus k, which is the order of the moment, and then you differentiate n plus k times n with respect to x, so the omega 1, and k times with respect to omega 2, and setting omega 1, omega 2 to 0. Very similar to what we have done for single random variable, except now we are differentiating with respect to omega 1, n times, because n with respect to x, and k times with respect to omega 2, because this is for y. واضح يا شباب how to find the joint moments from the joint characteristic function?
Yes.
Any question? As a relationship between the joint characteristic function and the marginal نسميها characteristic function is that the marginal characteristic function is equal to the joint when you set omega 2, for example, to 0, you get the marginal for x. While when you set omega 1 to 0, you get the marginal of y. As simple as that. Okay. Now let's talk about a very important concept, which is the jointly random variables. This is very important, and we will see it a lot when we talk about random processes later in chapter 7 or chapter 6. Sorry. Jointly Gaussian random variables are specific type of random variables that are jointly نسميها jointly Gaussian. ايش يعني jointly Gaussian? Jointly Gaussian means, first of all, the two random variables x and y are each Gaussian. هذا أول شيء. كل واحد فيهم لازم يكون Gaussian. So x and y هاي نسميها jointly Gaussian random variables if أول شيء the two random variables are each Gaussian. يعني كل واحد فيهم is Gaussian individually. The second, x and y satisfy f x y, x and y as this. هذه jointly Gaussian PDF. Okay? Now we'll talk about it in a minute. So I will say the two random variables, every one of them has to be Gaussian individually. إيش يعني Gaussian? Means that they are characterized only by the mean and the variance. For example, x has a mean x bar and a variance sigma xy. And the mean of xy, of y, sorry, is y bar, and the variance is sigma y squared. Then, okay, so basically x here is a normal distribution with x bar and sigma x squared. And y is normal with y bar and sigma y squared. هذا أول شيء. So every one of them is Gaussian. The second thing is they are jointly Gaussian. Jointly Gaussian means that the PDF, the joint PDF satisfy this. What does this mean? This, if you look at a single Gaussian, لو تتذكر single Gaussian fx of xy of x of x ايش كان شكلها؟ لو تتذكروا يا شباب 1 over 2 ها sigma x square 2 pi under the square root لو تتذكروا right؟ خليني بس اكتبها بطريقة مختلفة شوية عشان 1 over square root of 2 pi sigma x e to minus x minus x bar divided by square طبعا 2 sigma x square. نتذكر كذا كان شكل الجاوسن right؟ الآن in jointly Gaussian for the x part we have the same. For the y part we have the same. نفس الشكل. Okay? نفس الشيء y minus y bar all square divided by sigma y. لكن بدون 2 لأنه 2 حاطينها برا نحن هنا. So we have here in the x it's Gaussian. لو تلاحظوها. In the y it's Gaussian. في الوسط في term related to اللي يشبكهم اللي يشبك الاكس مع الواي اللي هو الكورليشن فاكتور. لو تتذكر الكورليشن فاكتور rho if we take expected value of x minus x bar y minus y bar and we divide it by sigma x sigma y we get rho. So if we take sigma x sigma y we get this. لو تتذكر C الرو كانت C xy divided by sigma x sigma y, right? So I can take C xy as rho sigma x sigma y. نفس الشيء. اوكي تمام. فالآن بس عشان نفهم how does the jointly Gaussian PDF look like? It looks like an x part which is x minus x bar divided by sigma x squared, a y part which is y minus y bar all squared divided by sigma y squared, and then we have the thing that connects them together. ايش اللي connect them together اللي هي rho multiplied by x minus x bar y minus y bar divided by sigma x sigma y. الآن this whole thing طبعا في عندنا exponent we divided by 2 1 minus rho square, and at the coefficient هذا يصير كذا شكله 1 over 2 sigma x sigma y 1 minus rho square. What I'm trying to emphasize is that the exponent has the x part نفس اللي في ال single random variable. It has an y part which is the same as the single random variable y, which is Gaussian, and it has the connection part, the part that connects the two random variables through rho. So if rho is zero, what do we get يا شباب؟ ايش رايكم؟ If rho is zero, what do we get? fxy شكلها كيف يصير؟ شباب
2 multiplied by each other.
exactly. ليش؟ لأنه هذا كله يصير زيرو. معناها I have only a single an x part and a y part. وهذا يصير زيرو. Sorry, يصير 1. Okay. So basically I have x of x multiplied by fy of y. You see it? واضحة يا شباب؟ So what does this mean? It means that uncorrelated, هذه rho equals 0 means uncorrelated, right? Jointly Gaussian random variables x and y are also independent. لو تتذكر احنا قلنا independent معناها uncorrelated، لكن uncorrelated مستحيل ما لها علاقة بالindependence. Uncorrelated ما تعطينا أي معلومات. However, for jointly Gaussian random variables, if they are uncorrelated, then they are independent also. And this is only for jointly Gaussian. واضحة يا شباب؟ طبعا this is very powerful result. It means that if you have jointly Gaussian random variables, then in order to check whether they are independent or not, you don't really need to build the PDFs, the joint PDFs, and verify them and so on. You only need to look at the correlation factor, our covariance. If the covariance is 0, means خلاص, these two random variables are independent. And it's very powerful when you talk about Gaussian random processes later. لأنه هذه تبني على هذه. طيب. Any question about this concept؟ الآن حنتكلم عن PDF كيف شكلها. Let's see the PDF. How does it look like? The PDF في the x-axis. So this is the PDF, the joint PDF. In the x-axis, it looks like Gaussian. يعني if you draw هذا مثلا line, هذا the x-axis PDF. It looks like Gaussian and it's centered around x bar. في the y-axis, it looks also like, يعني if you look at only a specific x, in the y-axis you will see also a Gaussian, and it's centered around y bar. Now in the XY two-dimensional PDF, the PDF looks like what we call the bell shape. شكل الجرس. Okay? The bell shape. الآن if the two random variables are now البell shape هذا, if I look at the contours of constant values هذه أو هذه أو هذه, يعني basically I fix the value of هذه contour. Contours of fixed value, of constant value, of fx, y, xy equals c, constant value. هذه contours look like this. So now if I look at x versus y, كأني أطالع على I look at the PDF from top. So I will see this like the contour of constant value. هذه نفس هذه أو هذه. Okay شباب؟
اوكي دكتور.
Now the shape of the contour هذا gives you an idea about how the two random variables are correlated. And it gives you an idea about the variances of the two random variables. خلينا نرسم بعض الأشكال. Now, if the two random variables are independent, okay, and have the same variance, هيكون الكونتور شكله كده دائرة. Okay, so here sigma x equals sigma y, and rho equals 0. However, if we have x bar, y bar, if I have a shape like this, then sigma x ايش رايكم علاقتها بسيجما y؟ يا شباب
دكتور can you repeat the question?
إذا شكل الكونتور looks like this, هذا الشكل. What is the relationship between sigma x and sigma y? الفاريشن في الاكس دايركشن مقارنة بالواي دايركشن، ايش رايكم؟ مين اكبر ولا اصغر ولا يساوي؟
The x will be more. The variation
more.
of x will be more.
واضح رايت؟ لانه شايف انت الاكس كيف يتغير اكثر في رينج اعلى من الواي. And rho also equals 0 here لانه ما في tilting. الآن so basically rho equals 0, you have either a square, a circle or an oval. لكن oval ما يكون معوج، يكون في يا اتجاه كذا يا اتجاه كذا. الآن بالعكس إذا أخذنا شيء زي كذا.
vertical.
Yes, exactly. Now sigma x is smaller than sigma y, واضحة. And rho is still 0. Okay? Now, when do we start? So either when rho equals 0, either you see a circle or an oval that is horizontal or oval that is perpendicular. هذا إلى الآن rho equals 0. When rho is not equal to 0, you start to see tilting of this contour. يصير شكله زي كده tilted, مايل. Okay? Now, let's see. If this is x bar and this is y bar, if I have a contour that is tilted like this, then rho is larger than, ايش رايكم؟ rho larger than ولا smaller than 0؟ هنا مقارنة بهذا. ايش كيف نقارن هنا؟ ايش رايكم؟ في اول كيس rho is what؟
Positive.
Positive correlation. ليش؟ لأنه as x increases, what happens to y?
Positive direction.
Yes, y increases. الترند واضح إنه positive correlation. بينما الثانية rho s less than 0. ليش؟ لأنه as x increases what happens to y? Y decreases.
decrease.
Okay. So you need to understand التأثير أول شيء variances of x and y and the تأثير أو effect of the rho on the contour. Now let's see some. Here we are plotting هذا ال PDF حق x و y. So basically both of them have the same variance. Okay. So basically you can see that x equals sigma y. Now this is for rho equal 0.4. This is for rho equal 0.1. And this is for rho equal 0.9. This is in 3 dimension. So we are plotting here the PDF. You can see that when you have a PDF, when rho equal 0.1, it's like circular. It's like a bell shape that is circular. لأنها قريبة من زيرو. ما في tilting كثير. When rho equal 0.4, you start to see some tilting. تحس إنها متحركة شوية. When rho equal 0.9, you can see that how tilted it is. هذا now if you look at the contour اللي هو الكونستنت اللي قلنا عنه تلاقيه كذا. بينما هنا ممكن تلاقيه ما هو كبير، ما هو واضح. هنا تلاقيه almost circle. هذا تلاقيه شوي يعني بس ما هو واضح. هذا تلاقيه مرة tilted if you look at it in 2 dimension. So here we have rho 0.5. Rho equals 0 and rho equal minus 7.5. Okay. For rho equal, طبعا when you look at the 3-dimensional plot, you don't see it very clearly. You can see here and see here. يعني الفرق ما هو كبير. However, if you look at only the heat map or surface, when you look at the surface, you can see that طبعا هذه ايش عبارة عن ألوان. كل ما يصير اللون لونه أحمر أو يعني يروح قريب من اللون بدل الأزرق أحمر أقرب للأحمر يصير ايش؟ الفاليو أعلى. يعني هذه توصل للقمة هنا اللي هي هنا. This is the largest. As you are more green and then blue, then the value is small. مثل هنا. The number. So you can see here that in 2-dimensional, when rho equal 0.5, هذا rho equal 0.5, you can see that it's positive correlation. كل ما x تزيد, y تزيد. While rho equals 0, there is no relationship. x تزيد, y ما في علاقة. While rho equal minus 0.75, you can see that as x increases, y decreases. And it's more oval than here. Okay? هذه minus 0.75 أكبر من 0.5. تحسها more focused towards the trend line. تمام يا شباب؟
تمام دكتور.
It's important to understand يعني it's very important to understand how does this joint PDF look like. إيش معناها؟ You can always remember the math لكن الماث ما يعطيك شيء. ما يخليك تتذكر، ما يخليك تفهم إيش العلاقة بين X و Y. So you need to understand the relationship between how to read this joint PDF. هذا الماث الإيكويشن اللي شكلها سطر كامل جزأنا لكم إياها in very small parts. الإكس part والواي part اللي هو لهم علاقة بالسنجل بي دي اف and the connection part أو correlation part. And how to read, what is the effect of the two sigmas, sigma x and sigma y, and what is the effect of rho? طبعا you can extend to multiple random variables. However, this is optional, so I will not cover it. But I will cover a very important concept اللي هي only the covariance concept of what we call covariance matrix لأنه حنستخدمها في أماكن ثانية. Covariance matrix عبارة عن شيء looks like this. It's a 2 by 2 dimension. It's a 2 by 2 random, matrix. Expected value of the following: x minus x bar, x1 minus x1 bar, square, and x2 minus x2 bar square, and then x1 minus x1 bar, x2 minus x2 bar, and we have here x1 minus x1 bar, x2 minus x2 bar, and we have expected value برا. Now what is خلينا ناخذ أول واحدة. What is expected value of؟ طبعا احنا عارفين expected value is a linear operation, means that it enters inside the matrix. What is the first one here? What is expected value of x1 minus x1 bar؟ ايش نسميه هذا؟ شباب.
variance of x1.
Exactly, the variance of x1 square. Your variance, sorry. يعني sigma x1 square. What about this part? Expected value of x2 minus x2 bar.
Variance of x2.
ممتاز. Variance of x2. What about the off diagonal? Expected value of x1 minus x1 bar, x2 minus x2 bar. ايش سمينا هذا؟ By definition ايش الشيء هذا؟
It will be x1 or multiplied by x2.
نعم. هذه expected value of x1 minus x1 bar x2 minus x2 bar. ايش سمينا هذا الشيء؟ المومنت هذا ايش سميناها؟ هذه central moment, central joint moment. ايش سميناها؟ يا شباب. طيب send me over the private chat. What is this? What is this, شباب? Over the private chat, send me this. What is expected value of x1 minus x1 bar, x2 minus x2 bar? What did we call this? يا ترسل إياها بالاسم يا الرمز. يا شباب. Quickly, I did not receive anything. طيب. طيب يا شباب quickly الله يخليكم. طيب في بعضكم قال إنه this is equal to the mean of x multiplied by the mean of y. في بعضكم قال this is the variance. شباب this is called the covariance cxy.
Variance, but the symbol I don't get it. I
It's
don't
okay.
get the symbol on the block in the.
It's okay. It's okay. So basically this is the covariance. هذه سميناها covariance. لو تتذكر covariance قلنا if this is 0 it means that they are uncorrelated. This is a very important moment. So basically the off diagonal is cx1 x2 and cx1 x2. هذه نسميها covariance matrix. Okay? Now if you look at it, cx1 لو تذكر cx1 لو نرجع هنا العلاقة بين الكورليشن كانت cx1 x2 divide by sigma x1 sigma x2 لو تتذكر صح؟ which means that Cx1 x2 equals rho sigma x1 sigma x2. And this is what we have done here. Okay? We substituted Cx1 x2 by rho sigma x1 x2. rho sigma x2 x2. هذه نسميها ايش؟ covariance matrix. And this is very important. You will see it when we talk about random processes, and you will see it whenever you talk about more than one random variable. أول شيء يسألك إياه إيش؟ أعطيني covariance matrix. Or you can define what we call correlation matrix. ايش correlation matrix؟ ايش correlation matrix؟ It's Cx. هذه هي covariance matrix divided by sigma x sigma y. Okay. طيب. So basically we established the fact that independent jointly Gaussian, when rho equals 0, you have this. We already established that. So jointly Gaussian and uncorrelated, they are independent. And this is only for jointly Gaussian. Only applies for jointly Gaussian. طيب أي سؤال شباب؟ Any question? Okay. طيب, I think time is almost there. شباب أي سؤال؟ طبعا this is self-study except this. This is included. The covariance matrix, correlation matrix is included. It's required from you. The self-study is the invariant. هذا اللي we will not discuss it in this class.
هل بيكون في كوز الاسبوع الجاي؟
لا خليكم تريحوا شوي.
زين.
إلا إذا تبغوا كيفكم عاد لكن. Let's give you some time. عندكم اختبارات ثانية and so on. طيب. أي سؤال يا شباب؟ So the self-study